Assalamualaikum and a very good morning to the panels. My name is Nurlana Izzati binti Kamidan. Today I will present on my final year project. The title is Removal of COD and Color from Batik Effluent by using sugarcane bagasse as an adsorbent. So this is my presentation outline. First, I will go through on the introduction, and then I will explain about the literature review, methodology, results and discussion, and finally the conclusions and recommendation. Batik industry is known as one of the largest industry that contribute to Malaysia's economy. However, this industry also produces wastewater with high concentration of pollutants which need an extensive treatment before it can be discharged to the environment. So basically, this wastewater contain the pollutants such as waxes, dyes, heavy metals with high COD and TSS contents. For the treatment of this wastewater, sugarcane bagasse powder has been proven to be a good alternative and a low-cost bioabsorbent to remove RR120 color. Next is the problem statement. Batik wastewater effluent are very high in COD and chemicals which can contribute to water pollution. Next, discharge of batik wastewater without a proper treatment by small batik industry, and existing batik wastewater treatment are too expensive, and finally, agricultural waste disposal problem. Objective of study. My objective of study is first to determine the characteristic of batik wastewater. Next, to study the effect of adsorbent dose and contact time on the removal of color and COD. And finally, to compare the effectiveness between fibrous sugarcane bagasse and powdered sugarcane bagasse as adsorbent. Wastewater sample was taken from local batik production in Kuantan and was preserved for the wastewater characterization purpose. The parameters that have been measured were pH, COD, BOD, total suspended solid, and color. Sugarcane bagasse was used as an adsorbent for the removal of color and COD from batik wastewater. Adsorption study was made in terms of the effect of adsorbent dose and also the contact time. So for the significance of study, this study can help small batik industry to treat the wastewater with a low-cost treatment. It also can contribute to existing data on batik wastewater treatment for future research. And finally, it can reduce the problem related to agricultural waste management, which is the leftover from the sugarcane bagasse. So here is some my literature review. As you can see, it is about the study about batik wastewater and also sugarcane bagasse as an adsorbent. Next, I will explain the methodology. So first, preparation of adsorbent. So there are two adsorbent used for this study, which is the fibrous and also powdered sugarcane bagasse. Next, the collection of batik wastewater sample. The wastewater sample was taken from DRM Batik, which is located in Kuantan, and then the wastewater was preserved for the experiment purpose. After that, characterization of wastewater. The parameter that have been measured is the pH. The parameter that have been measured were pH, TSS, BOD, COD, and color. After found out the characteristic of the wastewater, the parameter with high reading will be treated by using adsorption. So, in this study, powdered and fibrous sugarcane bagasse was used as adsorbent. First of all, the effect of adsorbent dose was studied. The dose that have been used is 2 gram, 4 gram, 6 gram, and 8 gram for both powdered and fibrous. After that, the effect of contact time were studied, which is 15 minutes, 30 minutes, 45 minutes, 60 minutes, and 75 minutes to find the optimum contact time. Then, from the results, we can calculate the percentage of removal of color and COD. After the calculation have been made, these two adsorbents will be compared in terms of the effectiveness to remove the color and COD. Now I will explain the results and discussion. First, the Batik effluent characteristics. From all the parameters, only 3 parameters show a height value, which is the pH value 10.43, COD value 855 mg per liter, and a color 235 ADMI. So these 3 parameters were chosen to be treated using sugarcane bagasse. For the effect of adsorbent dose, the adsorption of color and COD increased with the increment of the amount of sugarcane bagasse used for the treatment. As for fibrous sugarcane bagasse, the adsorption process reached its equilibrium at 6 g per 250 ml for the color and COD removal. For the powdered sugarcane bagasse, the adsorption process of color removal reached its equilibrium at 4 g per 250 ml, while for the COD removal at 6 g per 250 ml. So as you can see in the graph, the further increment of adsorbent dose did not affect much on the adsorption process, because the adsorption has reached its equilibrium condition at the optimum dosage. So for the study of contact time, the optimum dose which have been successfully determined in previous study were used, which is 6 g per 250 ml for fibrous and 4 g per 250 ml for powdered sugarcane bagasse. The optimum adsorbent doses were mixed with 250 ml of Batik effluent in a conical flask and shook by the orbital shaker at 100 rpm. At the desired time interval, the sample was withdrawn from the conical flask and tested for its color adsorption by using UV spectrophotometer. So the efficiency of color removal reached its optimum at 60 minutes for both types of adsorbent. After 60 minutes, no further removal of color takes place in the adsorption process. It is observed that the percentage removal of color increased as the contact time increased. For color and COD removal efficiency, the percentage removal of color is about 32% for fibrous sugarcane bagasse and 36% for powdered sugarcane bagasse. As for the COD removal efficiency, the percentage removal of COD is about 63% for fibrous sugarcane bagasse and 70% for the powdered sugarcane bagasse. You can conclude that the powdered sugarcane bagasse is more effective in removal of color and COD from the effluent. So, for the conclusion, color and COD show a height value of 235 ADMI and 885 mg per liter respectively. Color and COD were chosen for the treatment using sugarcane bagasse to remove the excess amount of color and COD. For fibrous sugarcane bagasse, the optimum dose was 6 g per 250 ml for both color and COD. As for powdered sugarcane bagasse, the optimum dose for color removal was 4 g per 250 ml, while for COD removal was 6 g per 250 ml. It can be observed that for the color and COD removal, the percentage of removal increased with the increment of the adsorbent dose. So the optimum contact time for both forms of sugarcane bagasse was at 60 minutes duration. The maximum percentage removal was about 30% for fibrous sugarcane bagasse and 32% for powdered sugarcane bagasse. The maximum percentage removal of COD was about 62% for fibrous sugarcane bagasse and about 70% for powdered sugarcane bagasse. Powdered sugarcane bagasse is more effective in removal of color and COD compared to fibrous sugarcane bagasse. As for the recommendation, it is recommended to control the pH value of the wastewater, and sugarcane bagasse can be activated by any acid or base to increase its effectiveness. Sugarcane bagasse can also be made as activated carbon for wastewater treatment. This study can be made in terms of the effect of pH, surface area, temperature, and concentration. So that's all from me. Thank you so much for listening.